Right.
Okay, so
we'll make a start
on
on this now.
The tutorial
The tutorial is probably just over an hour anyway, so we have time up our sleeve to cover this. So
I'm doing
two V6 tutorials this morning. The first one is looking at transition strategies. The second one is looking at deployment planning.
So
the first one is really trying to figure out where we go forwards from having,
I suppose,
just an existing IPv4 network.
Whereas
the second one is we've figured out how we're going to go about deploying V6, and it's looking at how you'd actually go and do it on the network infrastructure. So that's the plan for the tutorials this morning. I think part of the program committee strategy was to prepare us for Sunny Yuhi's presentation this afternoon, which is actually looking at the challenges of deploying V6 within a mobile operator's network, which is a tutorial I definitely want to sit through. I've seen a lot of the content that Sunny's going to be talking about. So if you want all three, I certainly recommend those for you.
Anyway, so
let's make a start of this. Good morning, all. My name is Philip Smith.
Worked
for some of my time for APNIC.
So
this tutorial is it's on my own webpage at the moment. It's on the APNIC 38 website now. I think it appeared there yesterday. So if you want to grab the slides, please do so.
I like all these things
to be more interactive than me just talk all of the time. The session is being webcast. So if there are questions, what I'll try and do is repeat the question for the benefit of the folks who are listening to the presentation. Also before I start, this set of slides was put together when I was working at Cisco. It was put together by the CTO and consulting engineering group at Cisco. Probably about 3-4 years ago. They have been enhanced since, but that's where this particular work started, because one thing that we found inside Cisco was a lot of customers are asking, well, what should we do? Obviously, if you go to a vendor, the vendor's going to propose all kinds of solutions to you. And one thing that was fortunate in our group, and some of you have probably seen Eric Fink around about earlier, Eric and I and a couple of others were trying to introduce really what we should be trying to do without just looking at product solutions. So I suppose we had an interesting time socializing this presentation within all the different product groups. Because it wasn't too friendly or useful for any particular product, and of course each product manager wanted their product to be promoted rather than an overall strategy in the organization. That's really where the slide set has come from, and there are quite a few other sectors of the industry are using similar slide sets to this to try and explain really where we are at the current situation, and what are realistic steps forward, and what the industry is actually doing, as opposed to the 101 different strategies that have been proposed over the years.
Anyway, so let's
cover the background first. And the first bit is really why we need to care. And we do need to care because, picking up Jeff Houston's graph from Potteroo.net, this is really tracking, in the blue line at the top, is tracking the IANA delegation. And you can see how they go pretty much from, I think that's about 1983.
And this
is the delegations IANA has made of address space out to both industry, the regional registries, and so forth. As the registries appeared in the early 90s, the IANA function partly became transferred there rather than the direct allocations that Internet were making.
So we see where
it all goes. We see the point there when IPv4 ran out. That's when IANA 2 was exhausted. And the various wriggles in the graph, partly resolution, partly address space that was handed back to
IANA, which has just most recently been redistributed to the RIRs, the /12 that each RIR received. What was it, about 3-4 months ago? So, and the graph also shows other issues, other matters, like how much of the address space that's been delegated is actually visible in the internet routing system and so forth. And you can see that, well, that number, which is advertised as this red line, it has slowed down since the V4 point ran out. You can see it started tailing off, but the number is increasing. So as the internet carries on growing, we're squeezing more V4 address space out of what is currently being delegated around the world. But it's pretty clear there that this red line will eventually reach that blue line, so we're slowly painting ourselves into the corner of no more V4 address space. So is it really running out? I mean, there's still people living in disbelief that, no, we can't possibly be running out. We most certainly are. IANA Free Pool, as you know, ran out February 2011. RAR Free Pool, okay, this is slightly different because each registry has slightly different run-out, I suppose, policies compared with each other. APNIC and RIPE-NCC have the same run-out. Basically, a single /8 was set aside in V4 with a very strict one-time assignment out of that final /8. So APNIC and RIPE-NCC are existing inside this process. ARIN and LACNIC have a different run-out process. Basically, you can only get small allocations and keep asking for these small allocations, which to me seems to just create a lot of work for the hostmaster team rather than actually share out a limited resource. Maybe I'm biased because I was the proposer of the final /8 policy for APNIC and RIPE-NCC, and looking for something that's trying to be fair to everybody seemed more reasonable from my point of view and my co-author's point of view. So here we're at. The interesting thing is, I mean, this is the INET, the folks at INECORE's widget that, I don't know, some people have on their desktop. Did that a few years ago, kind of bored with it now because it's really showing when the registries are going to run out. So this is all the remaining address space. Only APNIC has the luxury of having lots of address space left. They've still got over 3 /8s available in their pool. So the run out hasn't hit there yet. Although it's interesting, if you go to an APNIC meeting, there's a lot of discussion about what do we do about foreign, as in non-African-based organizations coming here, setting up business, pretending to be an African-based organization, to filter address space back home. Because none of the registries really have, you can only use our address space in our service region. There's no rule set like that. The community has never come along doing it. But those kind of conversations have been taking place, certainly in APNIC meetings that I've been to. And so that's an interesting thing that we can probably watch in the future. But if you look at this, LACNIC is sitting there with about 0.25 of the address space left. That's not very much, 0.25 of /8. And so it's predicting run-out times. Not quite sure why it's June 2014 is when they entered their run-out phase. But their run-out was, I probably got the number wrong. I think it was a /10 they had the limit at, and then they would do smaller and smaller delegations after that. So we're very, very close in certainly 4 regions of having almost no address space left. So it definitely is real. I mean, this is one of many different widgets that are watching what the registry space is. Yes?
What's the attitude to, in say, APNIC or LACNIC to foreigners actually taking the address space and actually using it? I mean, is it generally a negative connotation, or people accepting that? Or?
So Mike Bagbo was asking if there was a negative connotation in APNIC
Space in APNIC and LACNIC about in the communities about foreigners coming in and taking the address space. I got the sense, I don't know at LACNIC, but certainly within Africa, yes. There are known entities that are coming in and saying, yeah, we're now African-based business and all the rest, where they have no history of being there. And so they're going through the motions of looking as though they're there, and then spiriting address space, or using it elsewhere within the region.
Now, those folks are
Those folks are noticed because they're not known in the community. They're suddenly turning up and being very visible at APNIC and network operators.
So
there's certainly quite a bit of discussion about it. Yeah.
So the question
was about brokers being available and folks buying and selling address space, and whether it would help with the current situation, even though it's a limited pool. So basically helping distribute things around.
We have
to remember that the registries have different address transfer policies within the region. So for example, certainly within APNIC, it's possible for APNIC members to transfer address space, whether it's privately or enabled by a broker. Within RIPE NCC, same thing is possible. Within ARIN, the same thing is possible. Between registry regions, it's only between ARIN and APNIC, because the two local transfer policies align. But because RIPE NCC's transfer policy is different from ARIN's and different from APNIC's, there's no possibility to transfer from RIPE NCC outside the region or into the region. Not saying that. So this is, I suppose, the official transfer. It's quite possible that a broker is facilitating, or organizations are just moving anyway and hoping that nobody checks RIR registration information before you announce address space. So I suppose if all 5 regional registries had the same transfer policy, then yes, it would happen. But again, with the APNIC meeting, I think it was in Zambia last year, there was a transfer proposal proposed, and it was the most. Well, you don't have voting as such in a registry policy meeting, but this was probably almost unanimous no. But it should actually take place. We'll come back to the transfer bit a bit later on, but it was almost unanimous no that resources should be transferred out of APNIC internationally. The proposals had put in international transfer, so between regional registries. There wasn't even an intra-APNIC transfer proposal put in place, and that was a lot of rejection. Why are we setting up an international one? The domestic one doesn't even exist. So it was amazing. I've never really seen a policy discussion where everybody was against. It was only the people who proposed it who supported it. So it was interesting. I've been to a lot of policy meetings over the years. Strategies available for network operators. So we reckoned when we put this together that there were only 3. The first strategy is do absolutely nothing at all. So wait and see what competitors do. I guess that's what you kind of do. You're well established in your business. You don't want to take any risks, and so you just wait and see. You don't want to be the first one to jump off the cliff or whatever. Or maybe your business isn't growing, so you don't care.
Particular closed user groups or particular nations that have got more address space than they have population. They say, well, we're not growing, the network's not expanding, so we don't need to do anything. We only need to worry when people start switching v4 off. Extending life of v4, so forcing customers to use NAT. And that can mean making end-user address space more expensive as part of the service. Or start migrating network infrastructure to using NAT and so forth. And we'll cover those options as we go through the slides. Buying v4 address space in the marketplace. We've already had the question about the brokers and so forth. That's definitely an option as well. Deploying IPv6 is the third one. And that means a dual-stack infrastructure. I'll talk about that, what it means. Providing native v6, NATed v4 for customers, and using technologies such as 6RD, or DS Lite, 464 XLAT, or some other combinations of v6, v4, and NAT. A myriad of things have been proposed, but actually there are only a few ones that are seeing wide use, and there are only a few that really actually make sense for the future. So what I'm going to do is really look at these 3 options in a little bit more detail, look at the pros and the cons, well, how they work, the pros, the cons, and where they might be applicable, just to try and give a bit of guideline, I suppose, about what we would use each one for. So let's define some terms first. DualStack Network basically means we're running v4 and v6 on the same infrastructure across our network. So the routing protocols are handling v4 and v6 at the same time. Now, you are all aware that IPv4 and IPv6 have no interaction with each other at all. Both are completely independent protocols. So running v4 has no impact on v6. Running v6 has no impact on v4. And so certainly folks have been to workshops like we did as part of the conference last week. You saw that you could simply add v6 onto the network without breaking v4 at all. It had no impact. Well, unless you typed in v4 commands by accident. But generally deploying v6 over an existing v4 infrastructure has no impact on the v4 infrastructure. Also, DualStack means that content, application, services are all available on v4 and v6. So your end site, your website, your content provision is available on v4 and on v6. So the servers listen using both protocols. End users use the DualStack network transparently, and being very simple about it, if your DNS lookup returns a v6 address after you've queried for a domain name, the v6 transport is used. If no v6 address is returned, then the DNS queries for a v4 address and v4 transport is used instead. It's a bit more complicated than that. And certainly over the last couple of years, Jeff Houston has been looking at the complexities of a dual stack network and how the things actually behave. You've probably heard of Happy Eyeballs. Happy Eyeballs is available, for example, in Mac OS, in Firefox, and so forth, to ensure that, well, what it really does is test the v4 and v6 transport if both are available and use the one that works fastest, works best. And the different implementers have done it different ways. I'm not going to go through what Happy Eyeballs is in detail, but it's built into most operating systems and applications these days to give the end user the best looking experience. So the dual stack network today is certainly working a lot better than it was in 1996 when I first started playing with a lot of this, where it was very rigid. Right, we're going to try IPv6, and if it doesn't work, we'll wait till it times out, and then we'll use IPv4. And that behavior depended on which operating system you were using. So if you want to read about Happy Eyeballs, RFC 6555 has a lot of detail. I encourage you to have a look at Jeff's presentation, I think probably from about a couple of years ago, which looked at the different browser and operating system behaviors with and without Happy Eyeballs, because it's some pretty interesting stuff about what actually goes on. And then the third point here, it's envisaged that the internet will operate dual stack for many years, for some definition of many. And over the years, people always ask me, now, Philip, when will IPv4 turn off? And the answer could be, I suspect, never. I mean, if you look around today, is X25 still being used? Sure. Frame relay? Yep. ATM? Yep. So are we still using EGP, like the routing protocol before BGP? Probably not. I mean, Cisco's finally removed it from iOS, but still there's some very, very old protocols living and existing, and they're still there within networks. I don't know if anybody uses IPX. I think I was doing a workshop last year and I mentioned IPX, and somebody said, oh, yeah, there's still no servers using that. So I think in the infrastructure, there'll be places where you'll see IPv4 for a long time yet. For the end user, when would IPv4 be turned off? Again, hard to say. When I started off in the internet and we're persuading operators that internet was the future and using IP, they're saying, oh yeah, we'll get IP just to try things out, and but we'll still carry on using our traditional frame relay because that works really well. Within a couple of years, frame relay all gone. We were using IP over traditional HDLC, PPP, and so forth. So it could well be once the majority of content is all v6, available on v6, that a lot of sites will just go, yeah, there's no point trying to maintain the legacy v4 infrastructure. So please don't ask when v4 is going to be turned off, because we really honestly don't know. which means we're going to be running a lot of networks with both v4 and v6 for a long time yet. IP and IP tunnels, what does that mean? Basically, a mechanism where an IP packet from one address family is put inside an IP packet from another address family. So we want to carry IPv6 packets across a network that can't do IPv6. We put them inside an IPv4 packet, carry them out, other end pops them back out again, or vice versa. You know, we can carry IPv4 through an IPv6 only network. And this will allow an ISP to provide a dual stack service prior to completing infrastructure deployment. You know, they may have older equipment that can't do v6 native, so they put up a little tunnel through the device that can't do v6 to carry the v6 packets. So I've listed some of them there. You know, IP and IP is the standard one. GRE was the generalized routing encapsulation, which is what Cisco invented many years ago. There's 6-to-4, there's Teredo, there's Isotype, 6RD, MPLS, and so on and so on and so on. There are lots of others, I'm sure. But these are all tunneling techniques. We're encapsulating one packet inside another address family. There's address family translation, often referred to as AFT. There seems to be a trend in the last few years to have lots of acronyms and things, fancy words for things that we called very simply before. So, you know, AFT is another one you see thrown around all over the place. And it's like, okay, if you're, you know, nautical, then there's fore and aft, and what's all this? So, but address family translation refers to translation of an IP address from one address family into another address family. So it could be v6 to v4 translation, it could be v4 to v6 translation. Yeah, those are the typical ones that we're aware of today. Could be other address families as well, other versions of IP as well, but that's address family translation, changing between the different protocol types. This is one that we all know, NAT, network address translation. And to be pedantic, NAT is the translation of one IP address into another IP address, right? Being completely pedantic. What we generally see nowadays, though, is NAPT, which is a network address and port translation, where we translate multiple IP addresses into one other IP address, and where the TCP and UDP ports then distinguish different packet flows. So that's typically what you see almost anywhere these days. We still call it NAT, but strictly it's NAPT. So for example, your home broadband, right, you'll have one public address, you'll be using 192.168.1/24 internally. You're translating all those internal addresses into the one public IP address that your service provider is giving you. There's also something called NATPT, just to confuse things further, which is NAT protocol translation. But it's a particular technology that was defined by the IETF to do protocol translation, so between v6 and v4. It's now obsolete because it didn't work very well. And it's been replaced by NAT6.4, which also doesn't work very well. So, but NATPT, be careful, it's a particular translation technology between v6 and v4. We tried using it for quite a few of the conferences, quite a few of the Apricot conferences. When were we doing it? Probably from 2007, 2008. We tried it for 3-4 years, providing a v6 only wireless SSID, encouraging people to use it and tell us what worked. Well, actually, we asked them to tell us what didn't work, which turned out to be most things. It was very, very hard to actually get working properly. So it has been made obsolete, and we now have NAT6.4. Also, large-scale NAT. And this is just an ISP version. It's not a different protocol or a different translation technique. It's just standard subscriber NAT or subscriber NAPT, but done on an industrial scale. So millions of translations, generally on very expensive equipment with very, very fast RAM, very fast CPUs, and generally in very big boxes. And, you know, generally these days, large-scale NAT does a lot more than NAT. It does all the protocol translation, address family translation, you name it. So it's a catch-all phrase. So again, depending which marketing department you listen to, it's either LSN or CGN, carrier-grade NAT or large-scale NAT. So they are the same thing. So I don't know. I hope I don't use these interchangeably in the presentation, but you see a lot of people will refer to one or the other and they are the same thing. Let's look at strategy 1 of doing absolutely nothing at all. Yes?
I'm new to the community, so
Yes.
this may have been discussed already, but it seems to me that rather than build all of this translation and mechanisms to use both,
Yep.
why doesn't the community force the expiry of IPv4 and spread that responsibility to those who have services and applications and content to move to IPv6?
Yep.
Wouldn't that be much simpler?
It would. But the internet community has a history of not forcing anybody to do anything. I think it's a strength of the internet, but I think it's also a weakness as well. I mean, yeah, absolutely. And the thing is, when VSIG first started, when did I start going to IETFs? Probably 93, 94, when I started working in the internet industry. So when V6 first came out, probably end of 95, we had the first real internet draft for V6. We had a very, very early Cisco image when I was at UNet, running on a very old router. And the idea was, we'll develop V6 this year, we'll deploy it next year and turn off V4 the year after. That was the plan. But the problem is, the internet got too successful. And so certainly from like 96, 97, 98, all that folks were doing was, internet's the latest, greatest thing. Everybody has to get on there. So yes, V6 was all prepared and ready, but people were too busy. No, V4, internet growing, money, money, money. And so it kind of never really happened. And so the V6 development community spent a lot of time developing all these transition strategies to try and get, or technologies to try and get people to deploy V6. But there was never any, we're going to have a flag day where we turn off V4. It never really happened. So if I look at what we were doing at UNet in the UK, we had V6 native on our backbone in 1997, not offered to customers unless they asked for it. What was it? Verio NTT became, I think, the first tier 1 provider to deploy V6 natively in 2001. So we're looking back, 10, 15 years where we saw V6 being actually widely deployed, and the idea was, everybody should just turn it on. But as more and more infrastructure was V4, people went, it's harder. I'll do it next time. And so that's why we've ended up pretty much with people like me doing lots and lots of tutorials and lots of workshops, and the various V6 fora and the task force. Mike leads the Australian one. Just pushing a lot of this to try and happen. And maybe somebody does need to run the internet after all. But that's really why. It's well-meaning right from the start, but we've now gotten a situation where we have to do something, and it's really the big persuasion for folks to do it. So, yes, but very good question, very good point, and totally agree. But all right, so strategy 1, doing nothing at all. So nothing at all is this. So a V4 host sees the V4 internet. A DualStack host sees the V4 internet. A V6 only host sees nothing at all. And that's the situation we have today, pretty much everywhere. Well, not probably everywhere, but for many ISPs. There's no V6 for the consumer. V4 scaling lasts as long as V4 addresses are available. When V4 addresses are not available, then we have to figure out what to do next. Advantages, easiest, most cost-effective short-term strategy. Doing nothing is always the easiest and costs you the less. Costs you least for the short term. Disadvantages, your address space availability. As long as you can get address space from the registry or from the marketplace, fine. You've got no access to V6, so your customers end up doing other things to get access to V6 if they want it. If your customers don't know what V4, V6 is, then they just carry on living in bliss. Negative public perception of the service provider being a bit of a laggard, so you're not inventive, creative, forward-looking, leading the pack or anything like that. You're just providing services. Strategy will have to be reconsidered when you run out of V4. Who's this applicable to? Network operators who have enough V4 address space for foreseeable future business planning needs. I always kind of think that business planning is done on a 5-year thing, and if people are doing business planning on a 5-year thing, why they're not doing V6? That seems to be a kind of contradiction to me. So I wonder how many network operators actually do long-term business planning. Of people not heeding customer requests for v6. You know, I've had a running question every 6 months to my previous broadband provider here in Australia saying, so when are you going to do IPv6? Final straw was when they sent me an email saying that Australia doesn't need IPv6. Okay, cancel. So I moved to somebody who actually does do IPv6. But it's that thing, if customers are asking for it, shouldn't you be listening to what customers want? Have sufficient funds to purchase v4 address space via the marketplace. You know, some people have deep pockets. Oh, Philip, you don't understand, money is no problem. You're lucky that money is no problem. For most of us, money is a big problem. Strategy 2, extending life of the v4 network. So there are 2 ways of doing that. And this is the next step along from doing nothing. Once you've realized you've got to do something, what can you do? So you can force your customers to use NAT. I mean, certainly nowadays, if you're a broadband user, you're using private address space at home, your ISP will give you one address for your public address for your broadband router. Even that one public address is going away. RFC 6598 is service provider infrastructure address. That was I think it's a /10 that was set aside for backbone network operators who needed a private address space to NAT the customers into. Because if customers using, say, network 10 or 172.16 or 192.168, what do you NAT into? So we have another address block, 6598, that's set aside for those operators to NAT the customers into in the backbone without causing conflicts. And then they would NAT that address space out into their public v4 address space. So double NAT. Or you can acquire v4 address space from another organization. You can go buy the organization, standard takeover, mergers and acquisitions, and so forth. See quite a lot of that happening. Or the subnet trading. You know, we had the question asked earlier about the brokers. That's what the brokers in the business doing, encouraging, well, I suppose, subnet trading, to not mince words about it. I mean, that's what, it's a business for them, so they want to see their business working. And so certainly, as I was saying, within APNIC region, it's possible to transfer address space between members, and it's possible to transfer address space between ARIN and APNIC due to the transfer policies aligning. So let's look at SPNAT and a v4-only network. So again, v4-only host, customer router, does the NATing, of course. We NAT into private address space in the backbone, or RFC 6590 address space, and then the service provider buys a whopping big NAT box at their internet edge where they connect to the rest of the v4 internet. Still no access to v6, notice, right? The v6 only host or the DualStack host, there's only v4 available. So here we've gone shopping and bought a very, very big NAT box. This is such a simple picture, but the reality is you have to do a pretty major network redesign. If you're connecting to several different providers, from your backbone, you can't just whop in one NAT box and deal with all the upstreams simply as you used to before. It does involve fairly significant network redesign. So yeah, there are advantages of this. You can reclaim global v4 addresses from your customers, and it allows continued v4 subscriber growth because you've got a bit more NAT space and so on. Disadvantages, you need the big NAT box. You need an aggregation in the core layers, all the core layers. I'm not even going to start on all the technical drawbacks of NAT, but NAT has got a fairly serious list of technical drawbacks, which definitely security people just don't want to see NAT boxes used anywhere within the network at all. And of course, if your customers are providing content, how do you provide content, service provision from behind a NAT? You can do it, but you end up doing a lot of mapping and so on, and even then you need a heap of address space. So I've got 2 slides worth of problems with NAT boxes, so this is something we don't want to really head off down, unless you're prepared to put up with the issues. Double NAT is highly likely, as I mentioned. Sharing v4 addresses could have behavioral security and liability implications. Think about it. You know, if you're, say, on a mobile network, you're just happily browsing away. Somebody else is in the mobile network, happily browsing away. Your IP address that you have is the same IP address. Okay, using different TCP ports. What if the other person who's happily browsing away does something that caused this IP address to be blocked? Guess what? You end up being blocked. So the sharers of the single IP address that you're netting into have all the same network performance impacts and security impacts. Tracking association of ports, addresses, subscribers, lawful intercept issues. I mean, again, it depends which jurisdiction. You know, some economies, some countries require lawful intercept capability. They require logs of who was connected to the internet at particular times for many years in arrears. Are you going to keep all those? Is it for everybody running a netbox? So even a little hotel that's providing internet access for the guests, do they have to keep records for 5 years of which guest were using which IP address? Who's going to do that? May postpone v6 deployment for a couple of years. Sure, it can push off v6 deployment for a while. It still prevents subscribers from using v6 content services and everything else. So still, if you have a customer who wants to use v6, they will use other creative means to do so. So where's this useful for? Operators who are content to purchase and operate large-scale NAT devices within the core network. You know, I have talked about the operational issues, performance pitfalls. If you're doing millions of NAT translations, what's the throughput of the box? How much memory does it have? How many CPUs does it have? And so on. What happens if the box crashes? Has a problem, technical or physical or environmental? You've got a lot of customers who immediately disconnected. You are aware that your v4 network will have to be completely redesigned to accommodate these devices. They can't just sit in the middle of the core router because as you know, a lot of traffic paths are asymmetric. NAT boxes don't really handle asymmetric traffic paths very well. Well, they don't at all. So that's an issue to be thought about. Aware of suboptimal routing, the extra bandwidth requirements, able to reclaim public addresses from the customers. Most people have a contract with customers that says, you know, we'll give you whatever month's notice if we need to change parts of your service. Some of them just say, we're changing your service. Too bad. And of course, they're still not heeding requests from customers for v6 access. There's also subnet trading. The cost of getting v4 address space is low. If you go into your service provider, it's usually part of your the registry membership fee and the registration service fee. Each registry has different fees. The fees are set usually by the boards of the registry, depending on the operational needs. End sites usually receive v4 address block from the service provider as part of the service. You know, I have to pay for my public IP address that I get from my ISP. Many other people do as well. They may get a minimum basic default. If you want more than that, yeah, we'll charge you lots more for it. You know, it's quite interesting. If I want one v4 address here in Australia, I pay X, and if I want a subnet to be routed, they seem to add a 0 onto the price. So that's fairly significant cost just to get a v4 address on my network rather than using NAT. So in future, when the registries have no more v4 address space at all, cost of v4 addresses will be a lot higher. At the moment, it's close to not very much at all, close to 0 for network operators. Okay, never mind the non-availability, but if you can still get address space from the registry, it's your registry membership, which is very low per address. Of course, the price may well go up in the future. I think it was the Apricot in Kuala Lumpur. We had one of the brokers do a presentation. I think was it one of the lightning talks or one of the other presentations where they mentioned the typical address space for the different address block sizes. And it was very expensive, I thought, compared with just going to the registry and getting IP address space. So I imagine as the scarcity of v4 addresses increases, the price of v4 address space on the open market might even go higher. So looking at the issues of subnet trading, valuation of v4 addresses might hasten v6 adoption as the price keeps going up. Operators might go, whoa, I've got to pay all that much for v4 when, well, I can get v6 for nothing and just deploy it for nothing and I don't have to do anything. Even now to me, the numbers just don't add up for any v4 transfers, but obviously network operators think differently. And receivers of transferred v4 address space can prolong the v4 networks. Disadvantage is the market may not materialize. Right? There may not be a market. We've got lots of brokers. How many address transfers happen per month? I mean, APNIC reports at every member meeting how much address transfers they do per month. It's not exactly a major double-digit number. That's not a massive market, given the number of brokers that are there. Or maybe these are only the ones that are being registered by APNIC, and there are others happening that nobody knows about. Don't know. Depending on the region, if the registry doesn't register the transfer, there may not be routability. Some parts of the world, ISPs actually check the address space and who is registered to use it, and they will only route it if the registered user is the one that turns up saying, please route it. Other parts of the world, they don't care. They just do show us the money. Risk of the integrity of the routing system. The whole point of the registries is that there's a record of who's been delegated a particular address block. If it's then open season, how do you know who's meant to be announcing address space or not? This growth of the routing system, well, if you know me, that's one of my pet rants for probably the last 10, 15 years. Growth of the routing system, the v4 table, 510,000 prefixes today, 300,000 prefixes of that is junk, not needed. You can throw it away and you still get full routability across the whole internet. So as we see people saying, oh, I've got a couple of 24s I don't need in my /16, I'll go and sell them. Well, they can no longer announce this /16, so suddenly we end up with a lot more address space being routed because people are chopping up their address space. Kind of reminds me of 1992, 1993, when Internet stopped handing out Class Bs and starting out handing out big blocks of Class Cs. The routing table growth just went through the roof. It was way beyond exponential. It was almost a straight vertical line from what I remember, having to upgrade routers every 6 months, doubling memory and so on. And financial pressure on ISPs to dispose of the v4 addresses that they probably still need. I mean, I've seen that happen as well. People saying, oh, well, you know, we're a bit of a funding shortfall this year, and what I'll do is I'll have a couple of /16s that I don't need anymore. So if I go and sell those, you know, that'll bring my budget up too. It's short term, but you know, maybe they're jumping on an opportunity because v6 trading is happening at the moment. Somewhere I talk about, oh yeah, it's the next one, the reputation. So trading is fine if you've got enough money to go buying v4 address space at whatever the price is, $10 address, something like that. You're aware of the operational performance pitfalls, routability. What about legacy service provider filters? So the regional registries, all of them, before they start using a new address block over the years, they've announced address space from that address block 6 months before they start actually making delegations, with a message to the whole community saying, please check that you can see these announcements. If there are any legacy filters, please remove them. I've seen many operators who have put in IANA filters, IANA unassigned address space filters, and then forgotten about them. And the internet progressively disappears. Then they start phoning vendors up and other people. Bugs in your software. No, you're still filtering this /8, which Aaron has been trying to use for the last 4 years. Right, so there's a lot of legacy stuff hanging around like that. So what if the address space you've bought has got a legacy filter somewhere? Can you phone up the ISP and say, hey, you've got a filter that's blocking my address space. What are they going to say to you? Who are you? Probably. If they're not a customer, it's probably going to be, who are you? Do you care about them being registered or not? Well, your ISP may not care about them being registered, but what about some of the network operators who check every single thing in the registry databases? And a lot of them do. What about the reputation of the previous user? The previous user was, well, not a very good internet citizen, let us say. There may be, you know, the address space may be what's called toxic. You know, the last APNIC policy meeting with the whole discussion about what was it, network 1.2.3. /24 and 1.1.1/24. What was it? 111 is used by a certain vendor to auto-configure the printers, and so on. You know, you can go through the list of what's called toxic address space. You simply cannot use it because it's had a bad history before. So if you end up buying that address space, can you use it? No, you might end up with a 10 gigabit per second pile of junk traffic just because of what a previous user might have done with it. And of course, this is still useful for people who are not listening to customers about v6. So I think we've probably exhausted all the let's hang on to v4 for dear life opportunities. There may be others. There may be other reasoning, but I think when we were assembling all this and we started and over recent years, I think we've covered almost everything that's been a way of hanging on to v4. So let's look at v4 coexistence with v6. Coexistence transition techniques. Notice I'm not talking at all about migrating to v6. Migrating implies you've been there, v4 land, we're moving to v6 land. We're not. We're now going to be sitting in a world where we're 1 foot in v4 land, other foot in v6 land, in other words, coexistence. Right? So nobody should be talking about migration, at least not in, well, I think the current few years. As I was saying earlier, I don't really know when v4 is going to be turned off. It very much depends on when the content ends up all on v6 and people decide to turn things off. So we have 3 strategies for v6 transition: DualStack Network, 6RD, large-scale NAT. These are probably the 3 that we see being widely used. And again, we'll look at each one. I mean, large-scale NAT I need to chop up into other pieces as well because there are many aspects of large-scale NAT. DualStack was the original strategy. So again, if we go way back in time, 1994, when we're talking about v6, yeah, we're going to run the network with the 2 protocols side by side. 1995, we get it all deployed everywhere. 1996, we turn off v4, something like that. I mean, I don't think the years were ever specified, but certainly the talk in the room and in the corridors in IETF was, we're looking at this time frame to turn v4 off. And that strategy depended on enough v4 being available end-to-end. It's not just a case of, it's just the network operators would be dual stack. It was everybody, right down to the end user, would be dual stack. Windows 95 didn't come out with v6 in it. Nor did 98, nor did 2000. So you can see, that kind of strategy going off the rails. But that was certainly the original one. Does dual stack make sense today? Well, let's see. 6RD we'll talk about. It's an activity of the IETF Softwares Working Group. It's more and more wide use. Quite a few operators use that. Large-scale NAT. Your favorite vendors all have large-scale NAT boxes. They're very happy to sell you. And large-scale NAT, well, it can mean NAT 444, which is not a lot of use for v6 transition, but the boxes will do that. But they also cover, DualStack Lite, 464 XLAT, and NAT 64 itself. I'll look at each one as we go through the next set of slides. But again, each technology is part of the different working groups within the IETF. As you've noticed, the IETF have quite chatty names for the working groups. Most of these are acronyms or something representing what the working group is doing. You find the IETF network engineers, which is all of us really, like having these quite descriptive names. So, DualStack Network. Well, this is what the v4 piece is like. So I've drawn the v4 in red. So v4 host gets the v4 internet. DualStack host gets the v4 internet. We add v6. DualStack host can see the v6 internet, as can a v6 only host. So this was the original strategy way back. Depends on enough v4 being available for the consumer and the SP core. So this is the ideal goal. The ideal goal is probably long gone, but this was the ideal goal. Advantages: most cost-effective long-term model. All you have to do is run your network equipment with v4 and v6. Once everything's on v6, turn off v4. Disadvantages: v4 growth limited by v4 availability. Now, running dual stack requires extra staff training. Wow, I've done enough BGP workshops where I throw in a v6 component, people get excited, it's a v6 workshop. And then after D2, they go, it's boring. Because the numbers are different, everything else works the same, as far as the network infrastructure goes. So deploying v6, once you actually get a handle on the numbers and the big address space, it's boring. It works and looks the same way as v4. v6 on existing v4 infrastructure might cost extra in terms of hardware changes, RIB and FIB memories. this is where we should be listening to Jeff Houston's presentation, which he's going to be doing in 5 minutes, about 512. Anybody remember that? About 4 weeks ago? When, you know, Washington Post and a few others said, it's the end of the internet. Well, what happened was some Cisco and the supervisor 3BXL and 3CXL and a Brocade particular platform ran out of fib entries, 512 entries in their forwarding table, because that's what the box came out of the package or out of the crate, configured as. And none of the operators using them thought to actually check. Well, some did, but many did not think to check. Verizon, I think it was, accidentally leaked or increased the routing table by 10,000 prefixes, which popped these devices over the magic 512, and they dropped routes. People couldn't get access to certain websites, and then journalists had a field day. We've been here before. We were there before with the Cisco 3B and Supervisor 3, and what was it, Supervisor 2 something or other? 256,000 fib entries. But that's the point. Deploying V6, you turn on V6 in some of these boxes, what they would do is they would go, oh, I need V6 in my fib. So they move the partition between the V4 fib and the V6 fib to make room for V6. And the algorithm used was, oh, I've got 512K entries, I'll give 256 to V4, 256 to V6. So for 3,000 V6 prefixes, we need 256,000 fib entries. So there was none of this, let's be intelligent about it. I mean, it's the nature of the hardware. Whereas some of the other routers, it was a floating separation. But that was the issue. Some people said, I can't turn on V6 because my device can only have this partitioning between the V4 and V6 fibs. And if I turn on V6, I don't have enough room for my V4 prefixes without upgrading. Of course, the vendors love that because they can sell you a new route processor. So doing the upgrade was actually a serious bit for stopping them going to deploy V6. Even though the hardware was capable of doing it, it couldn't accommodate both full routes for V4 and V6. Also, V6-only endpoints can't access V4 infrastructure or anything, V4 content. So if we're going to do dual stack, everything has to be dual stack. If you get a V4-only site, it's not accessible by V6. And of course, the same is true the other way around. So this is fine for network operators who've got enough V4 address space for the future, may consider buying V4 address space when they run out, don't have any legacy equipment, don't have any legacy infrastructure, don't wish to buy large-scale NATs, and are happy supporting dual-stack CPE. Until about 3 years ago, dual-stack CPE was tricky, I think is the way of putting it. Nowadays, pretty much every CPE you can get will support V6. It's a complete change in the last 3-4 years, which is good. I bought a new DSL modem from my mother last year because Lightning took out the old one. New one has V6 in it. She's in the UK, dear ISP, my mother would like IPv6. Huh? What? Why? Why does she want that? So there's still that kind of reaction of, why do you need V6? Nobody quite follows it. But at least the CPE I bought off the shelf without any looking. I walked into the computer shop where she lives. They had 8 to choose from. Every single one did V6. So at least it's much more positive now than it was 3-4 years ago when we started writing these slides. And so note, this is considered the ideal option. Example, typical traditional internet service provider deployment. Whereas more realistically, we're here. We're going to have to start introducing service provider NAT. We've run out of V4 address space, so our customers are being NATed. Maybe we need to do NATing in our backbone as well. We add V6 into it. Sure, we can give native V6. Right? There's no NAT in V6. Well, that's what the ITF says. There's no NAT in IPv6. So we can give native V6, and of course we can still NAT for V4. And there's been a couple of conversations in the sessions up to now. Some people are saying 30-40% of their traffic is now V6 on their network. So that traffic would be following the green arrow, no NAT at all. Whereas the V4 is probably going to be NATed. And of course, you have different performance issues because you've got 2 NAT boxes adding in millisecond round trip times. If you have a happy eyeballs operating system like on here, then you're going to choose v6 more often than you choose v4, simply because the v6 is going to perform without NATs getting in the way, adding more milliseconds. So advantages, network operators can reclaim global v4 addresses, of course. It allows continued v4 subscriber growth. The service providers can offer v6 connectivity as well, doesn't postpone v6 deployment. Service provider needs a large NAT box. They know the deficiencies and the problems with it, but at least they don't have to do NAT for all the traffic. So the customer's going to likes of Google and YouTube and LinkedIn and what else, Facebook and so on, all the sort of major things that they'll be using. Akamai is the other one I forgot to mention. It's all v6. So your major download things that the end users are doing are going to be v6, v6, v6. So you just have to deal with NAT running through for some of the legacy things. So you don't need such a monster NAT box as you might have done if you were just doing, no, I'm going to use NAT for everything. So this helps a lot. It makes the prospect of using a NAT not quite so evil. And we've talked about the drawbacks of NAT and sharing addresses and blah, 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 blah. We talked about it before. A service provider also needs additional investment and operational expenditure to deploy v6 infrastructure. There could be the usual router upgrades, have to send people to a v6 workshop so they see how the routing protocols work. They've got to know how to use dual-stack routing protocols, ISIS, OSPF, BGP, figure out how the addressing is, and so on. Applicability for network operators who don't have enough v4 address space. I guess this is most of us. We're not all lucky to have endless v4 address. Again, willing to support dual-stack CPE. And as I say here, this is probably the realistic best practice these days. In all my travels and folks I've seen, this is where they try and go. And when they can't do this, then we look at other technologies that are available, and that's what I'm going to do in the next slide. So this is the typical internet service provider deployment. It's the simplest thing to do. We NAT the stuff that we can't get on v6. And as more and more content goes into v6, our NAT box is used less. So we have to use the NAT, but just a little, not too much. Next one, 6RD. The RD stands for Rapid Deploy. And this is used where the ISP infrastructure to the customer is not v6 capable. For example, it could be a v4 only BRAS, that's unusual. More likely, a DSLAM that can't handle the v6 ether type. Or you're running your infrastructure over something, maybe from another network operator who can't provide v6 transport support. And that does happen quite a bit. The folks who invented 6RD, or first used it free in France, had that exact issue. They didn't have access to the DSLAMs. They were just handed off their customers. The only way to do v6 was 6RD, and 6RD builds a tunnel, which I'll show you in a minute. So v4 runs native v4 as always. v6 runs through a tunnel, through the v4 infrastructure. The v4 only network can only carry v4 address, well, v4 protocol. So to get v6 through it, we have to put it inside a v4 packet and point that packet at this 6RD border router. What the 6RD border router is take the v6 packet out of the v4 one and then drop it onto the v6 infrastructure, and you can see the v6 internet. It's very simple. It's a very clever way of doing it. 6RD is actually a specific version of another technology called 6-to-4. You may have heard of 6-to-4. Please leave it like that. 6-to-4 no longer works. It used to work when nobody knew about it. I used it for many years. That was fine. Nobody knew about it. And then as more vendors started deploying 6-to-4 automatically enabled on the home routers and various other things, lots and lots of broken 6-to-4 infrastructure. And again, Jeff at APNIC Labs have done a lot of research about how well Teredo and 6-to-4 do not work. Don't touch them. They don't work. 30–40% unreliability is something that's no use for the network. So 6RD is a specific case of 6-to-4, where the 6-to-4 relay is actually within the service provider's own infrastructure. This works. This works very well. It's used quite a bit around the world where network operators don't have access to infrastructure that they're using for customer access or can't upgrade it. They may have invested in DSLAMs 3 years ago. with a 5-year lifespan, and these DSLAMs don't carry the V6 ether type, so they're stuck until the next upgrade. And I see that quite a bit. Even people buying DSLAMs nowadays that can't handle the V6 frame, which seems strange, but there we are. So that's 6RD. Advantages: the service provider has a very quick way of providing V6 access to the customer without deploying V6 across their infrastructure. It's not really meant to be avoiding deploying V6 where the devices can go dual stack. It's working around infrastructure that you can't upgrade easily, either because it's not yours or you've got to go push your vendor harder to give you the V6 support in it. Of course, 6RD supporting CPE, plenty of those available. So again, the cheap and nasty modem I got from my mum has 6RD in it, as well as dual stack, as well as something else I'd forget. So that's generally available as well. You're not going to buy a modem and have it working at home for 10 years. That'd be pretty unusual. We tend to change it like we change laptops and mobile phones and so forth. 6RD is completely stateless, so it doesn't really have operational drawbacks of 6-4, which it's based upon, and it doesn't postpone V6 deployment at all. I know quite a few people who are deploying 6RD pending other infrastructure upgrades in the backbone. Disadvantage: it's not the end solution. It's an interim solution. At some point, we want to remove the tunnel. The tunnel adds complexity. The 6RD border router, again, means we have to redesign our network a little bit because all the V6 traffic is going to run through there. We want to go native as soon as we can. Yes, the end users to upgrade their router modem they have at home, but as I say, they change it every 2 years anyway, so it doesn't really matter. And of course, you still have to use NAT and so forth for V4. Applicability: network operators don't have enough V4 address space, happy to deploy the large-scale NATs, have legacy equipment infrastructure which doesn't support V6. That's the main point, and realize that eventually will have to be upgraded. Dual stack CPE, need to run 6RD border router or routers. Generally, you could put one in per point of presence, because if you're only trying to bypass an old DSLAM, then you can have the 6RD border router even sitting on the BRAS itself. I mean, most routers that are BRASs these days should handle V6 easily enough. So you can have the 6RD BR there. So you make the tunnel as short as possible, rather than having the tunnel just landing in one point in the core of the network. Dual stack light. So let's turn everything upside down. Dual stack light starts from the assumption that we're going to run V6 only network. So if you look there in the middle, it says IPv6 only service provider network. Yep, so we've turned everything upside down. So we can give V6 to the V6 only host, we can give V6 to the dual stack host, and we can access the V6 internet. How do we support the legacy IPv4? Let's keep calling IPv4 legacy, because it is. So legacy IPv4, what do? Well, we tunnel the legacy v4 through the V6 internet. Right? We turn things upside down. So again, as I was saying, folks who were talking yesterday and the day before were saying, yeah, 30-40% traffic on V6. So it's all going to run over here. The rest of the V4 is going to run through this tunnel. Right? So the network operator runs V6 only. And legacy V4 support is through a tunnel to a large-scale NAT box. And then they can get access to the V4 internet that way. So again, the end user just has dual stack. They see V4, V6, everything works normally. V4 is slightly slower because it's popping through a tunnel and a NAT box, but otherwise they have end user dual stack. Advantages: service provider can get rid of V4 completely, apart from probably their edge, their border to their upstream and peers, whereas the backbone is V6 only. You can scale your infrastructure without worrying about V4. You can sell your IPv4 address space. No, it doesn't say that in the slides. Consumer can transition from V4 to V6 without being aware of differences in the protocols. Right? You've got dual stack there. V6 is routed natively. Disadvantages, of course, the NAT box needs to support DS Lite, and many do now. Subscriber router needs to be V6 capable. Many are now. And we've talked about the drawbacks of APNIC before. Fine for operators who are considering greenfield. Greenfield means starting fresh, new network operators. Right? Why bother deploy a legacy protocol? All you need to do is your end users who need access to the legacy until the content's on v6. So if you're starting off a new network operator, start here. Do v6 native end-to-end, and then figure out how to support v4 using DS Lite, for example, large-scale NAT. Mobile operators, that's one possible deployment, rolling out a brand new network with handsets which have dual-stack radios. I don't know, several people have said it, the future of the internet is mobile. You see the mobile operators, 4G. Most of the devices we have now are mobile of some description. Sales of laptops reducing, people are onto tablets, tablets use 4G networks. Sales of desktop servers, you go around any office these days, how many desktops do you see? Nah, laptops. Even in conferences now, I see people turning up, even coming to workshops with tablets. And it depends on the workshop, we've kind of got to go, well, you can't really do what we need in the workshop on a tablet. But that's where it's all going. People are using the tablets and mobile phones. Laptop is a bit more unusual. Desktop, buy a desktop. It's, you can look at Dell sales, for example, not to pick on Dell, but they can mention the sales of big boxes reducing. Internet's going mobile. So this is probably going to be one of the future technologies we will see quite a bit. 464 XLAT. I cannot do this justice, so Sunny Young goes through this in great detail after lunch. 464 XLAT is another technology that mobile operators are looking at, and it's pretty much the same. It's just lighter weight than DS Lite. So again, a v6 only service provider network, so v6 all goes native. v4 is, again, running through a tunnel, a simple tunnel, stateless IP to IP tunnel is built really between the customer router here, or it can be the mobile phone handset, again to a large-scale NAT box here. And that again handles the legacy v4 content to give you access to the v4 internet. Right? So some of the mobile operators in the US and other parts of the world are heading in this direction, already have deployed networks. So another technology, very similar. Again, you can deploy v6. You have no dependency on legacy v4. You just use your legacy v4 to give people access to v4 content that they can't get over v6. So if you want to use Skype on a v4 network, you have to run it through 464 XLAT because Skype doesn't work on v6, for example. Devices not supporting v6 can access v6 only networks as well, and then the v6 packets are routed natively. Disadvantages, of course, you need the PLAT box in the core, but those are fairly readily available. You need the NAT6.4 support, which includes a DNS 6.4 setup, which I'll talk about next. Subscriber router needs to support this stateless IP to IP translation, but again, those are fairly available. Some of the mobile handsets have those. Some don't. Model's got all the drawbacks of the SP-NAT model we've talked about earlier, but then again, we're only supporting legacy v4 through the NAT, and all the v6 stuff is running native. Again, I've just basically taken the same applicability as I did for DS Lite. So some of the mobile operators were looking at DS Lite, others are looking at 464 XLAT. And it's the same applicabilities. NAT 6.4 is worth looking at. I'm pretty cool about NAT 6.4, just I suppose more because of my bad experience with NAT PT not working very well at all. How NAT 6.4 works is, well, the v4 hosts, you don't get to see the v4 internet. But the DualStack hosts and the v6 host can do. And how it works is the v6 host, they'll do a DNS lookup. They'll look up, so they have the name, they'll look up the address. But the network operator has a special DNS server, a DNS 6.4 server. So the DNS 6.4 server will ask for a v6 address. If they get the v6 address, then we get v6 internet access. If the DNS resolver doesn't find a public v6 address, it asks for a v4 address and then fakes a v6 address based on the v4 address. It's a well-known range, and this faked v6 address is then, the packet is sent with that address to the NAT box, which then strips out the fake, uses the real v4 address to access the v4 internet. Right? So that's how NAT6.4 works. And some mobile operators are looking at using NAT6.4. The downside is the handset has to be v6 only. And that's fine. They save the $1 and the, 10 minutes of battery life by not having to support a dual stack device. I'm slightly cynical about the whole battery life thing and everything else, but apparently this is one of the reasons why things like this don't have v6 over the radio. So this is a slightly lighter weight for the end user because it is only single stack. But we have the downsides of NAT6.4, is a lot of things don't work through NAT. Again, we had a couple of Apricot conferences where we provided NAT6.4 access via special SSID, and we found out things that didn't work. I mean, Janog has mentioned about the NPT, which is the V6 to V6 translator that they tried, and what didn't work there. Again, lots of things. So, okay, and I've gone through a bit of the detail here about how it runs. We asked for a quad A record. If there isn't a v6 address, then the DNS resolver asks for a v4 record. It responds with a v4 address. The resolver fakes a v6 answer, a synthetic one. That then goes to the APNIC box, which then strips off the fake header and uses a v4 access to the internet. Right, advantages. v6 only consumers to access v4-based content without giving v4 address resources. So this is what happens inside v4 XLAT as well. Pardon me, what else? v6 services and applications can be offered natively to consumers. SP network runs v6 only, avoiding v4 dependencies. You need the NAT box, you need to support NAT6.4. Subscriber device needs to be v6 capable. There's no legacy support. All drawbacks of NAT, as I've talked about before. Useful for operators, again, it's the same as the others. Greenfield deployments, probably. We are starting off with a v6 only infrastructure. So we've got conclusions and recommendations. So this is going to be too hard to see. What we did here was we looked at each transition technology and compared various issues with them. So it's too hard to read, but this column here talks about prolonging v4. Business growth requires v6 deployment, coexist with v6 deployment. Operational complexity, we looked at complexity of troubleshooting, breaking end-to-end v4, because we always talk about end-to-end principles being very important. It's a dumb core, intelligent edge. NAT scalability issues, NAT scalability breaking v6. DNSSEC is very important, of course, trying to do DNSSEC. Lawful intercept issues. And we'll look at each one. v4-only network, I don't think is realistic. We're now in the v4-only network with NAT, so then we talk about some of the issues here. Troubleshooting gets a bit trickier with NAT. Dual stack, no v4, limited to v4 address availability. Right, we need v6 deployment, and so on. Dual stack with v4 NAT, right, moderate complexity, because again, we're introducing the NAT box. We'll compare 6RD with no v4 NAT, not realistic, really. 6RD with v4 NAT is. And then DS Lite, 464 XLAT, stateful AFT. So we'll compare each one. I mean, I think look at the slides later if you're interested, because it's trying to run through all these. It's kind of summarizing the presentation, and it's a bit hard to try and fit it all on the screen also. But generally, we're looking at complexity of operation. ISPs don't want a complicated network. We always talk about keep it simple and stupid, KISS. Very important fundamental of network operations. So things that introduces complexity makes it just too hard. Breaking end-to-end connectivity is a bit of a serious issue as well. You don't really want middle boxes. What are they up to? What are they doing? How do you do IPsec, encrypted tunnels end-to-end, and so forth? Comparing where the changes occur, v4-only network, nothing really has to happen. You may have to introduce address family translation if you want to access v6, though. So we start going dual stack, no NAT. Nothing needs to change unless the customer wants v6. If you dual stack with NAT, you're going to introduce NAT in your network. 6RD, not much has to change apart from changing the CPE, or Okay, you need the 6RD border router. So you see why this one is actually very appealing. 6RD because you don't have to change very much in the network at all. CPE needs to be changed and the 6RD border router. Whereas DSLite, 464X-LAT, stateful AFT, quite a lot of changes have to be made in the infrastructure. And so the scenarios could be these. You know, most content applications to move to v6 only. I think that's where we've always wanted to go. I don't know if it's really going to happen at the moment. Next 2-3 years, maybe 5 years. Most of the content applications offered v4, v6, well, that's where we are at the moment. You go to most of the major content providers, they're dual stack. Most of the users move to v6 only. Yeah, mobile networks. I think mobile operators, certainly deploying 4G networks, would be completely mad to even think of it deploying v4 today, right? v6 is the only realistic way of doing it. But I say this, and I've been to NOGS giving this very presentation, and the 4G operator comes to me, oh, but we did v4 because, oh, v6 is really complicated. Well, yeah, it is. But then you have to weigh up that complication versus how are you going to NAT 1 million users onto one IPv4 address or 2 IPv4 addresses? And seriously, I've found networks that are NATing 1 million users onto like 2 or 3 IPv4 addresses. Do the sums, it doesn't add up. So I can't imagine what kind of network they have. So, but this is the thing, you know, certainly the mobile networks, the 4G networks, really seriously have to be looking very hard at v6. And certainly we've seen the v6 presentations during Apricot and APNIC conferences. We've had a lot of mobile operators participating, which has been great, because those guys are really looking forward about what they have to do. And I'm sure they'll be very happy if you copy them. You know, normally they'll be very, very secretive and not letting on, but the fact they're sharing in a public forum like this, which is broadcast, webcast, recorded, and everything else, I think that's a very strong indicator that they're open and willing to share with what they're doing. Okay. Consumers can transition from v4 to v6 without being aware of any differences in the protocols. What's happened here? What's happened here? Did I push something? Have we just gone back in time? Right, where was I? I was on this one, I was thinking, I've done that already. Right, so yeah, most users moving to v6 only. No change. That's a potential scenario. No change. I see some countries have gone to, there's no change. I remember, you know, I've still got the email from my Australian ISP every 6 months, every year, well, my previous one, I should say, telling me that I do not need IPv6. Very nice of you to tell me I don't need IPv6. So they very much live in the belief that because they have enough v4 address space, we don't need to do anything until v4 is turned off. No change at all. Customers got no expectation of anything whatsoever. So, well, could be some of the broadband markets in Europe and the US, they're not growing, they're not new markets. But most of us in this part of the world, we're all what are classed as developing economies, we're all developing. We're all expanding, we're all growing, and so forth. So potential techniques, content applications moving to v6, so we can use v6 only network, why not? Dual stack, 6RD, 464X-LAT, DSLite as migration techniques. Content applications are on v4 and v6, all of the above, dual stack, maybe we need to use NAT. DSLite, 464X-LAT. Users of v6 only, there is NAT 6.4, but beware of the pitfalls, because a lot of stuff does not work v6 only. No change, we just keep buying the NAT boxes because our vendors say, this is a great product, and it will fit into your network very nicely. Or no change at all, the do nothing case. We're just, yep, nothing's happening, keep your eyes shut, plug your ears, nothing's happening at all. We carry on living in our little dream world. And you know, there's nothing wrong with a dream world until you get woken up and realize that everybody's using v6 and suddenly there's not much content left there at all. So recommendations. Start deploying v6 as a long-term strategy. Now, long-term strategy does not mean never. Long-term strategy is in your business planning. Like this is business planning thing, not like when you get told by somebody selling a product, oh, it's on the roadmap. Roadmap is a way of saying, we're thinking about it. We'll get round to it at some point when enough people give us dollars to do it. So start deploying v6 is a long-term strategy. And really how we start deploying v6 is what I'll talk about after the break. Start the deployment. It is really very simple. The workshops I've done are really boring for a network infrastructure operator. I'm not talking about end users. I'm not talking about inside corporates or anything like that. I'm talking about the backbone network operations infrastructure. Understand the current addressing usage. Do you have enough v4? Can you buy it on the open market? Have you got your final /22 from APNIC? Have you got your final /22 IANA recent distribution from APNIC? Because those two are available. Prepare a translation mechanism from the v4 internet to the v6 internet. Maybe you need to do that. Educate your user base on v6. Introduction, the use cases, troubleshooting. I mean, it's certainly better now with all the happy eyeballs. Right? I mean, I'm DualStack at home. I couldn't tell you if I'm using v4 or v6, and frankly, that's how it should be. I should not have to care. If I go to a website that tells me the IP address I'm using, it usually says v6. That's nice. That's sitting here in Brisbane with the provider I have. It all just works exactly as it should do. So anyway, those are the recommendations. I haven't made them very strong because we're trying to do this within a corporate function in Cisco. And when I've done these workshops under APNIC auspices, again, haven't done recommendations because I don't really want APNIC telling the industry what to do. But these are the realistic recommendations based on where we're at the moment, I think, from my point of view. And from the point of view of many folks who contributed to the slides. So that's really where I think we should be going. Anyway, so that's it. So after the break, I'll talk about deployment, just some thoughts about v6 deployment, how we go about doing it within the network. I'm not going to go into massive technical detail about things, but let's look at trying to build some deployment plan so we have a structure about doing it, not just jump into routers and start turning on v6. Anyway, so I hope that was useful or interesting. Happy to take questions during the break, because I think we probably should go and have a break now. Otherwise, see you after the break if you would like to come back. Otherwise, I'll see you during the rest of the conference. Feel free to send me email if you wish as well. As I said, the slides are on the APNIC website if you want to grab those. Thank you.